Hi friends, once again welcome back in our educational channel, that is SYJC Electronics. Friends, this is actually our 129th video lecture and this is fourth video lecture of our this topic, that is sequential logic circuit of SYJC Electronics, that is paper second, which is known as digital electronics, and from that paper second, these are our fifth chapters and this is our fourth lecture of this fifth chapter. Friends, now we are going towards our topic, our chapter. In this video lecture, we are going to study the concept of clock and clock flip-flop, and in this lecture we are going to study clock RS flip-flop. First of all, what is clock? Clock is nothing but the square pulse. The square pulse, when it is applied in digital electronics, this square pulse is known as a clock pulse. Why this clock pulse is used? Because this clock pulse has definite frequency. The frequency of this clock pulse remains same, it will not get changed. And that's why this clock pulse is used in digital electronics. Why it is used? In sequential logic circuit, the various circuits are used to perform the various operations and to synchronize the operation. To synchronize the sequence of that operations, some device, some input is required, and that input is known as a clock input. And by using the clock input, we are going to synchronize the sequence of operation. And when the clock pulse is used in that digital device, this device is known as a clock device. And in this case, this clock pulse is applied in flip-flops. These flip-flops are known as clock flip-flop. In case of clock flip-flop, the flip-flop we are going to change its state. The transition of state occurs only when the clock input is high. Only when we are applying high input, when the clock input is high, then only the flip-flop changes its state. That means the transition of state occurs. So basically there are two modes. One mode is known as disable and second mode is known as enable. So friends, what is disable? Disable means it is not able. That means when the clock input is low, the flip-flop is in disable mode. It is not able to change the state. It remains in a last state. So transition of state does not occur. This state is known as disable state. It is not able to change the state of the flip-flop. Disable. And the second state is known as enable. Enable means it is able to change the state. The transition of state occurs in this stage. This stage is known as enable stage. When clock input is high, the flip-flop is in enable mode, and as per the input, that is a trigger inputs, that is a set and reset inputs. Or in case of data flip-flop, it is a D input. In case of JK flip-flop, it is a J and K inputs. So as per the inputs, the flip-flop will going to change its state. The transition of state occurs. This stage is known as enable stage. So basically two stages, disable and enable stage. Clock flip-flops are further divided into clocked RS, clock D flip-flop, clock JK flip-flop, etc. And in this lecture, we are going to study clocked RS flip-flop. The circuit diagram of clocked RS flip-flop is now going to display on your screen. It is basically RS flip-flop. And along with the RS flip-flop, the two AND gates are used, and through that two AND gates, the clock inputs as well as the trigger inputs, that is the set and reset inputs, are applied to circuit, applied to the flip-flop. So the two AND gates are used. The input for AND gates are, the set input is applied to the first AND gate and the reset input is applied to the second AND gate, that is to the lower AND gate. The output of AND gates, that is output of first AND gate, drives the set terminal of RS flip-flop, while the output of lower AND gate drives the reset input of RS flip-flop. Along with the set and reset input, there is a common input that is known as a clock input. So that is logic diagram or constructional diagram of RS, clock RS flip-flop. In this case, the flip-flop is in enable mode only when the clock input is high. Now we are moving toward the operation, working of this RS flip-flop, how it stores the data, how it stores the bits. First, when the clock input is low, whatever may be the input, that is a set input and reset input, the output of AND gate remains low. Because in case of AND gate, output is high only when both inputs are high. Only when all inputs are high. In this case, it is a 2-bit AND gate. So, when both inputs are high, then only the output of this gate becomes high. But as clock input is low, whatever may be the set input or reset input, the output of both these AND gates are low. That means both set and reset inputs of RS flip-flop remains at low level. So flip-flop remains in last state, remains in previous state. That is our first condition. Now when the clock input is high, flip-flop is in enable mode, and as per the inputs, as a trigger inputs, the flip-flop is either in set mode, reset mode, in raise condition or in last condition. So first condition, when clock input is high. When clock input is high and both set and reset inputs are low, the output of both these AND gates remains low. That means the set and reset input of this clock flip-flop remains low and flip-flop remains in last state. We are getting the previous state. Next, when the clock input is high, flip-flop is in enable mode, set input is low and reset input is high. Clock is high, set is low, reset is high. Flip-flop now is in reset mode, and hence the output of flip-flop is now Q is equal to 0 and Q complement is 1. Flip-flop remains in reset. Next, once again, clock input is high. Now set input is high, reset input is low. Flip-flop now is in set mode. So output of flip-flop now becomes Q is equal to 1, Q complement 0. So flip-flop is in set mode. Next, once again clock input is high and both set and reset inputs are high. So in this case, the flip-flop is in raise condition, is in forbidden condition. We are not able to predict the output state. It is known as a raise condition or known as a forbidden condition. So that is RS flip-flop by using, that is clocked RS flip-flop, in which the clock input is applied and only the flip-flop is in enable mode only when the clock input is high. So that is clocked RS flip-flop. The symbol of clocked RS flip-flop is now going to display on your screen. There are 3 inputs. First, set input, then the reset input. These are the trigger inputs, and along with this there is a clock input, and that's why it is known as clocked flip-flop, clocked RS flip-flop. Now the truth table of RS flip-flop is going to display on your screen. In that truth table, there are 3 inputs. First, clock input, next set input, reset inputs, and the 2 outputs, that is Q and Q bar, Q complement. When clock input is low, whatever may be the set and reset input, output of flip-flop remains in last state. So that set and reset inputs are denoted by cross. The meaning of cross is don't care. We are not able to, we does not require to take the care. What is the state? That is the set and reset. It may be high or low. The output remains in last state. That's why it is known as a don't care. The second state, the second inputs, that is when clock input is high, set reset inputs are low. When both set reset are low, flip-flop remains in last state. So once again, outputs are last state or in previous state. Now when clock input is high, set is 0, reset is 1, flip-flop is in reset mode, so Q 0, Q complement 1. Next, clock is high, set is high, reset is low, flip-flop is in set mode because set input is high, so outputs Q is equal to 1, Q complement 0. Next, clock input is high, set and reset both inputs are high, so flip-flop is in forbidden state, output is unpredictable, so this condition is known as a forbidden, or that is known as a race condition. That is RS flip-flop by using clock inputs. So it is known as a clocked RS flip-flop. In next video lecture, we are going to study the next type of clock flip-flop, that is clock D flip-flop, clock data flip-flop. So friends, thanks for watching this video lecture. Bye. Take care. See you again.